Hi guys, Sanbonani, Dumela, Kunjani. Welcome to Matrix Uploaded. My name's Mark, and if you've turned on your television set for the first time, welcome to mathematics in South Africa. We're going to build the nation. Now, grade 10s, 212s, you must be listening. Grade 10s, let's kick off. We're going to do some exponential equations. There's some new stuff that's in your curriculum. Have a look at this one. If you've got to solve for x, now look at that. The exponent is an x. Now listen, 5 to the what is 25. Logically, 5 squared. Nothing in it. So, but let's develop some techniques here. What do we know? Okay, if that's 5 to the x, what we can do is 25 can be written as 5 squared. Remember, 5 squared is not 10, but 5 squared is 5 times 5, which is 25. Now watch this. If you look at this carefully, we call these guys the 5's bases. Okay, very important. Notice there's a therefore and then the equal. Now, the idea is to say, well, look, if these are equal, what must x be? Well, it's got to be 2 to make it 5 squared. So in essence, what we do is they say in maths, if the bases are the same, we equate the exponents, or more simply put, we kind of like drop those bases and we make the exponents equal to each other. Okay, now let's have a look at another one. If you look at this one now, this looks a bit strange because if you think about it, the bases are the same, but there doesn't appear to be an exponent here. Now be very careful. Many matrics even, they say what that answer is going to be 0. Careful. There's an imaginary 1. Remember, 2 is the same as, check it out, 2 to the exponent 1. Now the bases are the same and we must have 2 exponents there. So 2 to the 1 is 2, and that makes sense because look here, 2 to the 1 is in fact 2 to the 1. Okay, so x has to be 1. You equate the exponents. In other words, you put them equal to each other, you drop the bases. Okay, now watch out for that. Another one. Let's have a look here. Example 3. Well, 7x is 1. Or you might be saying this is a problem because the bases are not the same. But think about it. 7 to the what is 1? 7 to the? Yes, someone in the Cape. Yeah, it was the Cape. I'm sure it was Cape Town that said it. Someone in the Cape. Brilliant. 7 to the naught. I can hear you. Well done. Gee, the South Africa's getting good at maths education. Now listen, 7 to the naught is 1. Now, that's brilliant, but now, what can we do to get the bases the same? Well, 1 is 7 to the naught. And then we can equate the exponents, and x is naught. These are very important basic principles. They get a little bit more tricky, so stay with me. Okay, let's move on now. Example 4. Look at this one. This one's a bit dodgy because the bases are definitely not the same. So we've got to do something with the 16 and the 32. Now the worst thing you can do is try and divide both sides by 16. There's an exponent, so you've got to be very careful. Well, think of 16. Well, what do we know? And 32, what do we know? Well, think of this. Think of base 2. 16 is 2 to the 4. The exponent 4. Think about it. 2 times 2 times 2 times 2. You've got 4 2's, and 2 times 2 is 4. 4 2's are 8, and 8 2's are 16. So what a pleasure. 2 to the exponent 4 is, of course, your 16. What about 32? Well, if we've got the 16 times 2 gives me 32. So if you think of it as 2 times 2 times 2 times 2 times 2, that's 2 to the 5. Okay, so now the bases are pretty much the same, but I think what we need to do is we need to sort this out a bit. Now remember from earlier years when the exponents are like that, you need to multiply. So 4 times x is 4x. And guess what? We've got the bases the same. So we can drop the bases or equate the exponents. Now we've got a very simple equation, and x is 5 over 4 if you divide by 5 by 4, and we always like to make it a little bit, nice looking 1 1/4. What a pleasure. Okay, now let's get a little bit more technical. What about this one? Now this is awkward because we can't cancel those because of the exponent. So what we can do is, I think, let's divide both sides by 2. So bring the 2 underneath and let's get rid of it. Now, the problem, there's a half, and that's 8. All right, guys, well, let's see what we can do. If you think of as 2 to the negative 1, what do you know? that is the same as a half. So if we reverse it, well, what a pleasure. We can make a base of 2. So let's do that. So what we can do is we can say a half is 2 to the negative 1, and there we go. And then, of course, we can multiply these guys. Minus 1 times x, there we go. And 8 is 2 cubed, and the base is the same. Drop the bases. There we go. And very easily, the minus 1 goes across, becomes 4. And there we go. Now, that's quite nice. Now, what about this one? Have a look at this. This is nasty. X to the half. How can we get rid of the half? Well, very simply put, if you square both sides, if you put a 2 on both sides, the half of 2 is 1, and x is 8 squared, which is 64. And then here, the same. If you bring the 5 across, minus 5. Now, let's cube both sides to get rid of the 1. So if it's 1 over 3, you simply multiply by 3. Okay, and there you go. And x is equal to 125. So you can see, guys, the solution is x is 125. Okay, so when you've got the fractions, all you're doing is going to, if it's 1 over 3, put a 3 onto both, and there you go. Don't go away. Stay with us on Matrics Uploaded for some more divine mathematics.